I do just want to clarify something. They have to turn in their 1.2 and 1.3 worksheets to you, right?
Yes, the 1.2 and 1.3 worksheets, they're not due until Sunday.
Okay.
Yeah, I believe that's Sunday.
Okay.
But let me make one. Let me just check, because if I'm not mistaken, no, the 1 1 and 1 2 worksheets were due last week. So, well, I should say at the beginning of the week, Sunday. So this
1 3 1 4.
yeah, 1 3 and 1 4 is due Sunday. And yesterday they were supposed to complete the lesson checks for 1 3 and 1 4. Now,
I have a quick question.
sure.
I due to just like family reasons, I was unable to get on and upload the 1.2 worksheet to you. Is there any way I could still upload it for credit, or is it too late?
Well, I'll let you go ahead and do it for now. You said the
Thank you. It won't happen again.
You said the 1.2 worksheet?
Yeah, the 1.2 worksheet.
Okay. So you submitted the 1.1 worksheet.
Yeah.
Okay. Yeah, you can go ahead and submit the 1.2 worksheet.
Thank you.
I will, hold on one second. Okay. I'm going to make it due today by 3 p.m. So you got to get it turned in by 3 p.m. today.
Okay, thank you.
Okay. All right. Any other questions? All right. Now, before we get started today, because we are a little ahead, which is always good, I want to know, did any of you have any questions about the class setup, Alex, or anything? Because I've been getting emails from people concerning Alex, about them not being able to sign up for Alex. So is everyone signed up for Alex here?
I'm good.
I can get in and do everything fine.
Oh, okay.
I'm also good.
Okay. All right. I'm just trying to be sure, because a lot of people
Can I ask a question for another student too, as far as the students, what they see in Alex?
Okay.
So when you log in and look at Alex, do you just see the Pi Progress and the quizzes now? And then the Pi Progress works towards those lesson checks. Is that correct?
Yes, that's what I see.
Okay. All right. So that makes sense. There was a question from another student. So does it show that you've worked toward those lessons, or does it just show that you work toward the Pi? That makes sense.
Has any of you paid attention to that?
So Lakeisha, is that yes for the, no, that was from before.
All right, Ms. Stewart is asking you all these questions just to make sure that everything is working properly.
Yeah.
So if one of you all could answer the question for her, that would matter of fact, let both of us know that everything is working properly.
Everything is working properly on my end. I don't see any problems.
Okay. So you just check in, you do your Pi Progress, and you do your quizzes. And
Yes, it makes it every time that I get done with I guess it's example or practice, it
Mhm.
moves me on, and then it'll tell me at the top that I have went to the next. I only have one left or two left, and then it congratulates me, and then I go on. And
Okay.
then when I go back in, like if I log out and go back in, it automatically tells me on the pie how much more I have to do to get to the next topic, I guess.
Okay. All right. Sounds great. Thanks, Nicole.
You're welcome.
And then if you click the menu option, if you click under the assignments, it'll tell you exactly what you've completed, and it'll also tell you what's still due, when it's due, and everything like that. So if you've completed all the lessons, it'll say 100% complete, so it'll give you a percentage.
Okay. Great. Thank you so much.
Yes, thank all of you all for letting us know that information. Okay, so now let me ask this question and then we will get to today's lesson. Well, two questions. Number one, have you all received your workbooks yet through the mail?
I got mine a couple days ago.
Anyone
I
else?
picked.
Anyone not
I,
get it?
I went and picked mine up.
Okay.
I received mine as well.
Okay, great, great, great. Okay, so since no one here has said they did not receive it, can you all turn to page 77 in your workbook? So I know this is going to make it a lot easier as far as us working out the problems here. Okay, and then the next thing that I wanted to ask, I don't know if any of you have watched any of the videos for the course, but I was curious to know if you watched the videos and were they helpful, like if you had any suggestions as far as any changes you think should be made to the videos. Okay, so I guess silence is golden here. All right. Okay, so I guess with that, since no one has a response to it, I guess we can get started here. All right. On page 77, the title of this here, it's all relative. And if you notice here, we do have a picture of Albert Einstein here, one of the great intellectual minds of the 20th century. Okay. So it says compare change to relative change. Oh, wait a second. I got to do one thing here. I need to share the screen. Okay, it says, can everyone see the screen quite well? Anyone cannot see the screen?
Looks good to me.
I can see it.
Okay, all right.
The writing on your course pack, it's clear, but maybe a little smaller.
Okay,
Looks
let me
good
see if
though.
I can make it larger. Let's see.
That's great. Yeah.
All right, because I don't think we're going to need the graph per se. So I'll make this a lot larger. Okay, again, the title is all relative. The learning objective is compare change to relative change to apply percent error. When you sit with a nice girl for 2 hours, you think it's only a minute. But when you sit on a hot stove for a minute, you think it's 2 hours. That's relativity. Okay, that's a nice way of putting it. When asked to compare the sizes of two numbers, most people think of subtraction. But the example above shows that this isn't necessarily the best choice. The change between two quantities is found by simply subtracting a new value from the old. This is sometimes referred to as actual change. Now, what they're talking about as far as the example is this here. Let me read this. It says, in a nutshell, Einstein's theory of relativity says that even the passage of time is not an absolute, but rather is relative to your frame of reference. In this lesson, we'll study appropriate ways to compare numbers, focusing on the importance of relativity. Consider these two scenarios. I owe you $20 and I give you $10 instead. Will that work for you? Number two, you win $5 million in the lottery, but you only get paid $4,999,990. Would that ruin your day? You're out $10 either way, but clearly that's a much bigger deal when the amount owed is $20. If that makes sense to you, then you have an instinctive understanding of the concept of relative change. Okay, now, if we look down here, as far as the change is concerned, we have actual change here, which is the new value minus the original value. So that's basically it for actual change. Now, when we look here, relative change at the bottom here, relative change is the new value minus the original value divided by the original value. What formula is that similar to?
Is that the was that the percent increase?
Yep, percent increase and percent decrease. Exact same formula. Now, the only difference between relative change and the percent increase, percent decrease is that with percent increase, percent decrease, your final answer must be a percent. But with relative change, your final answer can be a percent or a fraction or even a decimal. Does everyone follow that?
Yes.
And also one other thing too, with percent decrease, remember how I told you all that even though it might be a negative number that we don't write the negative, right? With relative change, you have to write the negative. So that's like the only other little change. So it's not that big of a change. Now it says here, for my first scenario, the relative change is 10 minus $20 over $20. And then we will have a negative 1/2 or a negative 50%. The negative indicates that you got shorted. Bummer. This shows that the change between the amount owed and the amount received is half of the amount owed. That's a big deal. Find the relative change. If you win $5 million and get paid $4,999,990, write as a fraction, not a decimal. Okay, so you'll take this $4,999,990, subtract your 5 million, and divide all of that by your 5 million. So this will give you a negative 10 over 5 million. So they want us to write this as a fraction. Divide both of these by 10, it'll be a negative 1 over 500,000. Now we know a negative 1 over 500,000 on the surface, as far as the money you lost, this is a smaller amount than this negative 1/2. Does everyone follow that? All right. So number 2, it says compare the relative change for the two scenarios in the opening paragraph from this lesson. Does this match your intuition about the scenarios? And the answer would be yes. $10 lost on $5 million is a lot less than $10 lost of $20. Now, that's a big difference. Okay, number 3. Your instructor tells you that you're going to get an additional 2 points on a recent test or quiz. Describe when this would be great news and when it wouldn't help very much. Does anyone have a scenario where that'd be great news and then where it wouldn't help very much?
I would say if the 2 points bumps your grade up, then it would help. But if it doesn't, then I don't think it would matter.
Okay. All right. And like you were going to say something. Guess not. All right. So piggybacking off of what Ms. Taylor just said, and I would just say this, I would say, I'm going to abbreviate this as GN for great news. Great news, I have an 88%, and then added 2 points, and say that would take me to a 90%. So that took me from a B to an A. From a 3.5 to a 4.0. Okay. And then it says, wouldn't help very much. So I put WHVM. You got a 10%, added 2 points to a 12%. Both are still low Fs. So those little 2 points really wouldn't do much. Any questions? All right, for questions 4 and 5, write a sentence that describes in your own words what exactly the given statement means. For example, when we found that the relative change from $20 owed to $10 paid was a negative 1/2. This means the amount paid was too low by an amount half of what it was supposed to be. The relative change in my budget was 7% compared to last year. Now, if you notice that 7% is positive, right? So this would mean that either it depends on how this person is talking about a budget. If this person is talking about available money to spend, then that means that he has 7 more, or they have 7 more percent that they could spend. But if they're talking about their prices went up and now their budget, they have to spend 7% more in order to maintain the same budget, that's a different scenario. So all you could say is the budget increased by 7%. So that would take care of either scenario. The budget increased by 7%, and I guess I'd say by 7% more than last year. Just so we'll know what we're comparing. All right. Now we move on to the next page. Number 5, the relative change in enrollment this year compared to last year at my college was a negative 3.5%. So basically what it's saying is enrollment decreased by 3.5% as opposed to last year. Well, as compared to last year. Now, for questions 6 and 7, write a statement using the term relative change or percent change to describe the information provided. This is pretty much the opposite of what you did in questions 4 and 5. Number 6, it says Apple's profit in 2016 was 14.4% lower than it was in 2015. So, the relative change was a negative 14.4% when comparing Apple's profit from 2016 and 2016. Okay, the value of my retirement fund was 5.5% more at the end of this year than it was at the end of last year. So, the percent increase of the retirement fund was 5.5% more than last year. All right. Now we go down here to the bottom. It says if you want some interesting reading, look up baseline budgeting. Currently, the federal budget has an automatic annual increase of 7% to many programs. Suppose that $435 million is spent for improvements to interstate highways for 2019. If the automatic increase of 7% applies to this budget, how much is expected for that program in 2020? All right, does anyone have any idea how we would go about solving this? All right, let me ask you all a question. We see that the budget was $435 million in 2019. If the budget would have remained at $435 million, what percent of the budget would that have been? Anyone?
That would be a 0% increase.
No, I'm not asking about the increase.
Oh, it would have been 100%.
It would be 100%. But you were correct, Ms. Webb. That would have been a 0% increase. But I was just thinking about the percent. So it'd be 100%. So if we have 435 million in 2019, 435 million in 2020, the budget as compared to the previous year would have been 100% because we kept everything, right?
Right.
Okay, now they tell us that the budget in 2020 increased by 7%. So what percent would that total budget be for 2020?
107%?
107%. Now, let me tell you why I'm having you all go through this process at 107%. What I have noticed in mathematics with a lot of students is that the more steps that you all have to do in mathematics, the more confused a lot of students actually become. Is that a fair statement?
Yes.
Okay, so I'm trying to cut out some steps here because let me show you traditionally how this would have been done. You would have took the 435 million, multiplied it by the 7%. Let me put that in Desmos. 435 times 0.07. That would have gave us 30.45 million. All right. That would have gave us 30.45 million. Then we would have took the 435 million and then added the 30.45 million to it. And our answer would be 465.45 million. That's the traditional way it would have been done. Now, by doing it this other way, and I'm going to draw a line to separate this. Remember how it was said that this would be 107%? So if we took 435 million and then multiplied that by 1.07, which is the same as 107%. Let me go here, make that one. The answer, we would have got the answer at one time. It would have just been 465.45 million instead of all the extra steps. So what do you all think about that?
I think that's different. It cuts down a lot.
I think it looks pretty good.
You say it's different and it cuts down a lot. Okay, listen, let's do this. I'm gonna call this the practical corner here. Okay, what we just did here, you can use this practically in everyday life. Whenever you go shopping, let's just say you're going for clothing or whatever, and let's just say, for argument's sake, there's no discount on the clothes. If you want to know how much you're supposed to pay when you get up to that register, you would take the tag price, and in Michigan, you will multiply it by 1.06. Because remember, we have a 6% sales tax, right? So you're going to pay 100%, which is the tag price, and then an additional 6% because of sales tax. So you can find out right there on the spot how much you need to hand the person at the register by multiplying everything by 1.06. Oh, thank you, Miss Baker. She said nice. Okay. So what do you all think about that? As far as it being some practical use.
We'll definitely be using that next time I go shopping.
Oh, okay. Love to hear that. Now I do have to give credit. You know, I like when you all are in the English and they tell you don't plagiarize and notate your sources when you're using someone else's material, right? So I would tell you, this young lady that I knew, I had never did this. Now here I am, a math instructor. I had never did that multiplying by 1.06. And this young lady told me about that, and I've been using it ever since. So I have to give her the credit. So it worked out really fine. Okay, now we're going to go over to page 81. We're going to skip over to page 81. I know there are two problems on page 80, but we don't actually need to do those. So we're going to go to page 81. It says, next up is a really useful topic that's related to relative change. We've already talked quite a bit about estimation in this course. In most cases, when some quantity is estimated, there's going to be some error in that estimate. When comparing an estimate to an exact value, the error or actual error in the estimate can be expressed by subtracting the actual value from the estimated value. That is, error equals estimated value minus actual value. Does everyone follow that? All right. So now I want you to see this. Estimated value is basically your new value, and actual value is actually your old or original value. Does everyone follow that?
Yes.
Now,
Yes.
if you notice this formula here, estimated value minus actual value divided by actual value. So this is basically the same formula we just got through using. New minus old over old, or we can say original. So the estimated value is always the new value. So when you see estimate, that lets you know that that is the new value. And the actual value is actually considered the old value or the original value. All right. Now it says some sources use an absolute value in the numerator of this formula so the percent error is always positive. But since we're all about interpretation in this course, we'll want to preserve the sign so that we could tell if the estimate is too high or too low. If you're ever in the market for some new carpet, you might consider searching the web for the Carpet Buyer's Handbook. This site has many useful resources on buying and installing carpet. It turns out that figuring out how much you're going to spend is more complicated than you might think. Carpet is sold by the square foot, and you can measure the square footage of a room, but you can't buy exactly a certain number of square feet because carpet comes on rolls of a certain width, usually 12 feet. If you need a 2 by 3 foot piece for a closet, you can't buy just 6 square feet. You have to buy 2 feet off the roll, which would be 24 square feet. In addition, there are certain guidelines that installers would adhere to in order to get the best result. These govern how the pieces off the roll can be situated, leading to more potential waste. The bottom line is that when a professional installer measures a room to estimate the amount of carpet needed, the result will usually be quite a bit different from the actual square footage that will be covered. Now we look at number one. When you're buying carpet, do you want to overestimate or underestimate? Explain.
I would say an overestimate, just in case there's a miscalculation in square footage.
Okay. Overestimate. Anybody else?
I would overestimate just to make sure I had enough in case we made a mistake and cut it wrong.
Okay. Anybody else? Okay. So basically, you want to overestimate just in case the measurement is wrong, or to make sure it's enough to cover the surface, which is basically what both of you all said in a nutshell. And then also, just piggybacking on this too, if you don't have enough carpet and they're laying your carpet, you're going to have to do like a lot of other people do, basically get some type of china cabinet or something to set over the missing part. And I know none of us want to do that.
Mm-mm.
As you see that done a lot with paint. A lot of people don't
Oh
buy
yeah.
enough paint, and then they'll put a dresser over the spot where they didn't have enough paint for.
Mm-mm.
Or if you ever go in people's garages or basement, you usually see 1 or 2 cans of paint that's left over. Because they always have to, overestimate it. Now, we come here. A carpet installer estimated that 24 2/3 square yards of carpet would be needed for the bedroom and closet shown in the diagram. Find the area of just the bedroom in square inches. Now, if you look here at this bedroom, and we're not talking about the door openings or the closet, just the bedroom. Remember, area is equal to length times width because this is in the form of a rectangle. So here, the length is 182 inches, and the width is 128 inches. So we multiply these two, 182 times 128. So this would be 23,296 square inches. Now, number 3, it says find the area of the closet in square inches. Now, basically the same formula here. Area is equal to length times width. The area is equal to, the length is 64 inches, and the width is 50 inches. So the area is 3,200 square inches. All right. Now we come here to the next problem here. It says each of the doorways shown is 30 inches wide, and the walls are 4 inches thick. Carpet is needed for the entire doorway between the bedroom and closet, and then half of the doorway into the bedroom. How many square inches does this add to the total carpeted area? All right, so basically we have our 30 inches times 4 plus we will have our 30 inches times 2. And that would give us 30 times 4 plus 30 times 2. So that'll give us 180 square inches. All right, now it says here, oh, wait a second. I got rid of the decimals. Okay. It says here, convert the total carpeted area. Oh, wait a minute. I didn't finish this up. How many square inches does this add to the total carpeted area? What is the total carpeted area? Okay, so basically we need to add all 3 of these values together. So we have 23,296 square inches plus 3,200 square inches plus 180 square inches. So we add all of this up. 23,296 plus 3,200. Let me go back. Won't let me do it. Okay. 3,200 plus 180. All right, so that gives us 26,600 676 square inches. All right, now, the next question. It says convert the total carpeted area to square yards. Round to one decimal place. You may find it useful to look back at the colored box on converting area and volume measurements on page 64. Okay, listen. If we want to convert these square inches to square yards, first of all, we need to know how many square inches is in a square yard. So let's just do a regular yard. It takes 36 inches to equal to 1 yard. Because as we know from our English measurement, 3 feet is equal to a yard. And changing feet to inches, that'd be 12 times 3, which gave us 36. Now we want to do square inches. So we'll take this to the second power, and then we would take this yard to the second power. Now 36 inches squared is 1,296 square inches equals 1 square yard. Now we want to convert this, so we would take the 26,676 square inches, put it over 1, and multiply by this conversion factor. It'll be 1 square yard over 1,296 square inches. The square inches simplify each other out. So you add 26,676 over 1,296, and that'll be square yards. Now we'll put this in a calculator. 26,676 divided by 1,296. And it said round to 1 decimal place. So this will be approximately 20.6 square yards. Any questions? All right. Number 6. It says write a sentence or two describing how the professional estimate compares to the actual carpet area. Now remember, the professional estimate was 24 2/3 square yards. So if we convert that, it'll be 24.7 square yards by rounding it to 1 decimal place. Because 2/3 will give us repeating 0.6s. So round it to 1 decimal place, it'll be 24.7. And then we'll subtract off the 20.6. And this will leave us, 4.1 square yards. So professional estimate was higher by 4.1 square yards. Okay, number 7. It says find the percent error in the estimate. Round to 1 decimal place. Write a sentence explaining what this tells us about how the estimate compares to the actual carpeted area. All right, so we want the percent error. Does anyone have any idea how we would do the percent error? Okay, so we're still going to be doing basically the relative difference. So we'll change our final answer to a percent. The relative difference is the estimate minus the actual divided by the actual. Or as we say, the new minus the old divided by the old. So The new value is always the estimate. So the estimate is 24.7. The old value is the actual, which is 20.6. And we divide that by 20.6. So this will give us 4.1 over 20.6. So we want the relative change. It's about 19%. Well, I'll just round it. So if we do well, might as well say 20%. It's approximately 0.20%. So the estimate is about 20% higher. The estimate is about 20% higher. And it tells us we should get some money back. All right. Okay, this is the last page from section 1.5. Well, actually, it's the last 2 pages. Okay, it says here, not everyone realizes this, but when you buy carpet, you pay for the estimated amount, not the actual amount covering your floors. If the family that owns the house in the diagram picked carpet that costs $28 per square yard installed, how much would they have paid? So we would have to go to the estimate, which is 24.7 multiplied by $28. So this would be $691.60. Use the actual error in the estimate to find the dollar value of wasted carpet. All right. So here's a question for you. How do you think you would figure out what is the wasted carpet? What would you need to do?
Find out what's actually used.
Right. So in line of that, you would take the estimate minus the actual. And then whatever that answer is, you will multiply by $28. So the estimate was 24.7. The actual was 20.6 times $28. So this here gives us 4.1 times 28. So this would give $114.80. And that's a lot of money on wasted carpet. It says, according to the internet, which knows everything, a good rule of thumb is to plan for 5 to 10% waste when buying carpet. How did the estimator do?
He overestimated.
Right, overestimated by about 20%, which is out of the range. It needs to be fixed. That's quite a bit of money just to be thrown away. Right now, we come to the back here, number 11. It says, one suggestion for estimating carpet is to measure each room in inches and round up to the nearest half foot and ignore the doorways. Using the measurements for the closet and the bedroom, make an estimate for the square feet needed. I don't think we actually need to necessarily do that problem, but I know we definitely, we don't need to do number 11. Let's look down here at number 12. It says, list some situations where relative change is a much more useful number than actual change. All right. What if we said an average person loses $1,000? That would be a big deal. But someone as rich as like Elon Musk or Michael Buffett, losing $1,000 wouldn't affect them that much. All right. If you, let's say that you was working with a personal trainer and you get shorted 10 minutes from your 30-minute workout, that would be a large portion of your workout. Does everyone follow that?
Yes.
Okay. Now you all can write that down. I'll repeat it. I said as far as number 12 goes, if the average person lost $1,000, that would be a big deal. But a person like Elon Musk or Warren Buffett, they wouldn't miss, well, they probably would miss it, but not as much as the average person would. Okay, and then number 2, if you lost 10 minutes of a 30-minute workout session with your trainer, that would be a big chunk of the training session, be 1/3 of the training session gone. Yeah, that would be a big deal. Okay. Okay, class, we are back. Did you all have any questions over anything from 1-5?
No, I'm good.
Okay. All right, so we're going to start 1-6. I don't know if we're going to be able to get through all of 1-6, but I know we should be able to get through the majority of it. So with that being the case, it says lesson 1-6, dead, bad, chocolate, good. Learning objectives: to convert numbers between decimals in scientific notation and to describe the significance of writing numbers in scientific notation. Worrying is like paying on a debt that may never come due. Will Rogers. According to an article posted to the website debt.org, in 2018, the average household in the United States has a little over $103,000 in debt. This is the amount of money that they need to pay back at some point. That's not a good thing, and it sounds like an awful lot. Until you realize that as I write this, the federal government's total debt is, get this, it is, let me see, 22,617,716,240. If I were a betting man, which I'm not on account of being too cheap to risk losing money, I'd be willing to bet that over 3/4 of the population can't even pronounce that number, let alone comprehend how ridiculously large it is. For the record, it's 22,617,000,000,000, so on. If you decided to pitch in and help out, sending $10 to the government to help defray some of the debt, your contribution would amount to 0. Well, that's a lot of zeros, 442% of the debt. Thanks for the effort, big spender. In certain fields like governmental finance and the sciences, it's common to work with incredibly large or incredibly small numbers. Using regular decimal notation, this can be pretty cumbersome. Do 0.00, all them zeros and 4, and then another, a lot of zeros and 4, look very different to you. One is 100 times as big as the other. In this lesson, we'll use federal debt and melted chocolate to study a special way of writing very small or very large numbers in a more readable, convenient way. What do you think are some of the reasons we'll be interested in an efficient way to work with really large and really small numbers in this lesson? Okay, just think on that and we'll move forward here. It says, if you track the national debt over the last 90 years or so, you see that its growth, while alarming, follows a fairly consistent pattern. On average, the debt has grown by about 7.9% per year. If that trend continues, by 2050, it would be like 276,205 billion. And by 2100, it would be, let me see, that is quadrillion. Yeah, I think it's quadrillion. Yeah, 12 quadrillion, 300 trillion, so on. $300 trillion. If you're like most people, including me, so don't feel bad, you have no idea what those numbers actually mean. They're just too big to get any perspective on them other than, wow, those are really big. To make it easier to understand and work with numbers of ludicrous size, we'll use a clever method for writing them using exponents. Consider the number 300, which can also be written as 3 times 10 to the second power, which is, of course, 3 times 100. If you're thinking that's silly, hang in there. There is a point. Take a look at the first handful of powers. Okay, listen. We're not going to go through all of that. We're going to kind of skip through this a little bit, but I will do some explanation here. I believe all of you have worked with scientific notation before, correct? Anyone here not worked with scientific notation before or have never seen scientific notation?
We didn't get a chance to do a lot of it yet. We were so busy catching up on worksheets. So if they don't understand, I still have a lot of practice for them.
Oh,
I apologize. It's a while to get worksheets, yeah.
Oh, okay. No, I'm saying it's fine. What I wanted to know is they at least have seen it before. Yeah, have you all at least seen it before?
I'm familiar.
Okay. Now that is good that Ms. Stewart has more practice for you all, but I just wanted to be sure that you all have seen this before. So let me explain this about scientific notation. First of all, with scientific notation, you have a number that has only one digit in front of the decimal, that digit must be between 1 and 9. It can't be 0. It can't be negative. The one digit in front of the decimal could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's the only thing in front of that digit, in front of that decimal. Okay, now, that value will be multiplied by 10 to some power. As you see here, in number 1, you had 2.57. The number in front of the digit is one number in front of the digit, and it falls in that 1 through 9. And then it's multiplied by 10 to some power. That's scientific notation. Now, it says number 1, Earth is about 2.57 times 10 to the 7 miles from Venus, and about 4.67 times 10 to the 9th miles from Pluto. About how many times further away is Pluto? Okay, so what you would have to do here, you would actually have to do some division. So if you took Pluto, which is 4.67 times 10 to the 9th, you have to divide it by the miles to Venus, which is 2.57 times 10 to the 7th power, because we want to know how many times further away is Pluto. So we're comparing the two values. So what you could do, you could take your calculator, which we will have. Now, one thing I'm going to do, I'm going to put it here. The one thing that I always like to do with scientific notation is separate this. I would take these numbers here, the 4.67 and 2.57, and then multiply by 10 to the 9th over 10 to the 7th. And you'll see my reasoning in just a second. So we'll take 4.67 divided by 2.57. And that would give us, we have 1 point, it doesn't tell us how far to go. So it's 1.81712062257, and then times, because we want our final answer in scientific notation, 10 to the 9th divided by 10 to the 7th will actually give us 10 to the 2nd. Now, just a little quick rule of exponents. Whenever you have the same base and they're dividing, you subtract the exponents, and that will give you your final exponent. Okay, any questions on how I got these values here? Okay, so they asked us how many times further is this away. Now, we could leave it in scientific notation, but if you multiply this, this would be like 181 point all of this decimal here away from, away times further away is Pluto. So we multiply that out. We just have to move the decimal 2 places to the right. Now I'm going to write the number down here because I ran out of space. So it'll be 181.7120622257 times further. Well, I should have put miles. Times further. Yeah. Well, no, the miles would have simplified out. So it's 181.71, all those decimal times further. That's how much further Pluto is. All right, for questions 2 and 3, write each number in scientific notation. So this is the number they're talking about here. It's 329,697,000. Okay, so we want to write this in scientific notation. So first of all, we would do this. We need one digit in front of the decimal. we don't see a decimal here, so we know it's assumed to be here at the end. So we would need to move 1, 2, 3, 4, 5, 6, 7, 8 places. So it'll be 3.29697 times 10. And since we moved that decimal to the left 8 places, your exponent would be positive. If you were to move the decimal to the right, it would have been negative. Any questions? Okay, number 3. The distance in miles from Earth to the moon. So we had 238,900. We follow the same procedure. This decimal at the end, 1, 2, 3, 4, 5. So it'd be 2.389 times 10. And since we move 5 to the left, this would be to the positive 5 power. And that would be your final answer for number 3. Now, we also have negative exponents. Now, you can read the top at your leisure, but we're going to go over some problems here that requires you to use negative exponents with scientific notation. It says in questions 4 and 5, write each number in scientific notation. Now, they give you these two values as in between. I like how they space these so you will be able to count how many zeros you have without it it all going together. All right. Now, so it says it's in between 0.0000008 and then also 0.0000012. All right, so they want us to write this in scientific notation. So we got to move this decimal 1, 2, 3, 4, 5, 6, 7, 8 places. So this would be 8 times 10. We move to the right, so it'll be to the negative 8 power. Now we come here. We move this 1, 2, 3, 4, 5, 6, 7. So this would be 1.2 times 10 to the negative 7 power because we moved to the right. Now, one other thing that I need to say here is they tell us this is meters in length. So we'll put these in a parenthesis and put an M behind it to indicate that it's meters. But typically, if they don't give us a unit of measure, we wouldn't have it in a parenthesis. All right. E. coli is a common bacterium that can cause intestinal issues. A typical specimen is about, 7 millionth meters long. So we have 0.000007. Got to move this decimal 1, 2, 3, 4, 5, 6 places. So it'll be 7 times 10 to the negative 6 power. Oh, and you know what? They got meters too. So we'll put the parentheses and an M at the end. Now it says here, based on the size of the exponent in scientific notation, which is bigger, a small flu virus or a typical E. coli sample? Okay, the small flu virus is in between these values here. Okay, if you look here, this 7 is in the millionths place. If you look here, this 8 is in 100 millionths place. So this right here is larger than the first value. Now we go to the second value. Yeah, this is even smaller. So this is the larger value. The larger, the E. coli sample is larger. Now they ask us how many times bigger is it? So we would actually have to, I would say maybe we will go with the largest value here, which is this 8. So we could take the 7 times 10 to the negative 6 and divide it by the 8 times 10 to the negative 8 power. Now, when we do this, we have 7 divided by 8. Let me write that here. So it'd be 7/8 times 10 to the negative 6 over 10 to the negative 8. So we'll put this in our calculator, the 7/8, and that'll give us 0.875 times. Now we add 10 to the negative 6 over 10 to the negative 8. Now I'll just put this in the calculator here and let the calculator do it. 10 to the negative 6, oh, wait a minute. 10 to the negative 6, all over 10 to the negative 8. And it gave us 100. Now we know 100 is really 10 to the second power. So this would be times 10 to the second power, which we know is 100. We multiply this by 100, it'd be 87.5 times bigger. Yeah, I keep running out of space. So it'd be 87.5 times bigger. All right. It says, now that we're good at converting from decimal to scientific notation, it would seem appropriate, if not expected, to work on the reverse, converting back from scientific to decimal notation. So that's just what we'll do. Now we come here. It says, write each number in decimal notation. The number of red blood cells per microliter of blood in an average healthy man is 5.4 times 10 to the 6th power. Now, I know above in the tan box it goes over how to solve it, but I will talk you all through this. All right, so with that being said, decimal notation, and I want you to pay close attention to this. Decimal notation is the regular way we write numbers. So it's not a new way that we write numbers. It's a regular way we write numbers. So when you see like here, this was equal to 100, that's decimal notation. Here, let me see. When we got the 26,676, that's decimal notation. This here is decimal notation. All of these answers that we have here, it's not fractions, it's decimal or whole numbers, that is in decimal notation. All right. So now it says, so now we have to take this 5.4 times 10 to the 6th power. Now there's a couple ways we could do this. First, I want to show you how to do it in a calculator. So you would take 5.4 and then you would take times and then 10 to the 6th power. And they gave you the answer here. So we know this answer here is 5,400,000. Now that's how you would well, it's 5,400,000 cells per microliter. All right, so it's 5,400,000 cells per microliter. All right, so now that is how you do it in the calculator. Now doing it by hand, since you have 5.4 times 10 to the 6th power, and this 6 is positive, that means you move this decimal to the right 6 places. 1, 2, 3, 4, 5, 6. And all of these blank spots, you'll put zeros in them. So it still will give you 5,400,000. And that's still cells per microliter. Okay, so that showed you how to do that by hand and also using the calculator. Now it says the mass of an average human ovum is 3.6 times 10 to the negative 9 power kilograms. I actually should have had that in a parenthesis, but that's fine. Okay, so now we can use the calculator or we could do this by hand. Doing it by hand, we have to move, since this is negative 9, we have to move this decimal 9 places to the left. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of these spots here would be zeros. So this will end up being 0.0000000036. And that'll be kilograms. Any questions? Now, of course, you could put that in your calculator as well. All right. Go here to number 8. It says when a number written in scientific notation has a positive exponent on 10, what can we say for sure about the number? The number is greater than or equal to 10. The number is greater than or equal to 10. Does everyone follow that?
Yes.
Mm-hmm. It says if a number between 0 and 1 is written in scientific notation, what can we say about the exponent on 10? A number between 0 and 1 is written, okay. So if a number is between 0 and 1, that means it's a decimal. It'll be 0 point some number, okay? So if that number is between 0 and 1, then what we would have to do is this here. It says, what can we say about the exponent on 10? That the exponent is, wait a minute, the number is negative. That the exponent is negative. Because remember, a number between 0 and 1 is about, let's just say it's 0.5. That's between 0 and 1. We have to move this decimal 1 place to the right, and that'll be 5 times 10 to the negative 1 power. Anytime we move that, have to move that decimal to the right. When we're moving from decimal to scientific notation, that means that exponent is going to be negative, which is basically what they're saying here. Okay, number 10. It says fill in the blanks. If a number in scientific notation has a negative exponent on 10, to convert to decimal form, move the decimal place blank because the number is blank. Anyone have any idea what would fill the blanks?
I would like to see.
You say
I said to the right because it was negative.
right.
Good answer.
I mean, it's better said. I want to see it though. I'm like, oh,
I like that one. That was the one I liked.
right.
Okay, now watch this. Let's just take a number that's written in scientific notation. Let's take 5.35 and multiply it by 10 to the negative 3 power. Okay, so far so good, right? It says if a number in scientific notation has a negative exponent on 10. We got that there, right?
Right.
Okay, now to convert to decimal form, move the decimal place. Will we move it to the right or will we move it to the left?
I said to the right.
Yeah, but if you move it to the right, wouldn't that make that like 53 or 535?
You're right. That's why I said I had to see it because I don't know.
Yeah, that's fine.
It's confusing, but I'm willing to learn.
Thank you. Okay, so this right here, you have to move it left. So we move the decimal place left. So we would do that. That'll be 3 places. So it'll be 0.00535. That would be the answer to this, right?
Yes.
Now it says because the number is what?
Which number though? Are they talking about the exponent number or the number we just got?
This final
Oh,
answer here.
because it's positive.
Well, that is true. It is positive. All scientific
Okay.
notation numbers are final answers are positive.
Okay.
Okay. That's true, but it's something else.
Is it because it's less than 10?
You said what? Say that one more time.
I'm sorry, is it because it's less than 10?
You talking about the final answer?
Yeah.
You're on the right track.
Okay.
Very close.
Less than something.
It's less than 1.
It's less than 1, but what else? Go and read the first 7 characters of problem number 9. Read that.
Yeah, Lakeisha got it.
Got it.
The
Because
rest
it's
of
an exponent, or because it's between 0 and 1.
Because it's between
Oh,
one.
it's
Yeah.
more than
Number is
Gotcha.
between 0, I'll write out the word, and 1. It's between 0 and 1. Because it's not going to be 0 and it's not going to be 1. It's going to be some number that falls in between them when you have a negative exponent. Everybody fine with that? Well, I hope so. All right, now we look here at the bottom of page 95. I think, if I'm not mistaken, I think 96 is the last page we have to cover from this section here. So it says, write the result of the calculation on the calculator screen in scientific and decimal notation. Now, I don't think I've seen this, unless Ms. Stewart, you could tell me this here. I don't think I've seen this on Desmos with this E.
Right.
Have you seen it on Desmos?
No, that's the TI-84, right?
Right, yeah, that's a TI. Okay, so if you're using one of those TI products, which is fine, if you're using that, then you will end up getting an answer somewhat like this. Now, is there anyone using the TI calculator? Anyone?
Yeah, Desmos just shows it just the way you write it on paper.
Well, let me just show it on a TI calculator, because I just want to be sure that I'm not missing anybody. Let me pull it up real quick.
I know, I just practiced in Desmos just to make sure I was telling you the right thing.
Okay, here's a copy of the TI calculator. Some of them may be a little bit more fancy with the color or whatever, but it's basically the same thing. So I'm going to type what we have here in this TI calc. Wait a minute, it got the E. Let me type this out. Let me just type a large number. Let me go to mode. Matter of fact, I don't even have to type a large number. I'll just go here to mode and then type in, say I type in 567. Now it gives you 5.67 E2. Now what that E stands for, just to show you all this, E is equal to 10, and then the number behind it is the exponent of the 10. So E6 is equal to 10 to the 6th power. Well, I should say times 10 to the 6th power, because it's usually a number in front of it. So it's equal to times 10 to some power. So when we see this here, this is the same as 7.44 times 10 to the 3rd power. Does everyone follow that?
Yes.
Okay, I wanted to thank you. All right, now, with that being said, they want us to write this in scientific. We already wrote it in scientific notation. And then decimal notation. So this would be one of our answers. Our other answer would be we would need to move this decimal 3 places to the right. So it'd be 7,440. And that's it for problem number 11. Says at the bottom, in the opening paragraphs for this lesson, we pointed out that when a large number is written in decimal form, it can be pretty difficult to even know how to pronounce the number. In scientific notation, however, is easier provided that you know the powers of 10 that correspond to various numbers. Some common examples are provided in the following box. Say 100, 10 to the 2nd, 1,000, and so on. Now they did skip some like 10,000, 100,000, and yeah. So all right. So now we move on here. It says here the size of the national debt in dollars for selected years from 1930 to 2019 is shown in the table and the graph. In the third column of the table, write how the debt would be read aloud. Okay, now, since they have E and plus 10, they're not saying 1.60E and then you add 10 to it. They're just telling you that this E is to the positive 10 power. Okay? So this is basically, just to show you off to the side, this is basically 1.60 times 10 to the 10th power. And then that'll be 10 to the 11th power. Then 10 to the 12th power and 10 to the 13th power. So they want us to write out what this means. So this right here is 1.60 is 16 billion. The 5.10 would be 51 billion. And that's dollars. And then now we got the 11th power. So this will end up being 257 billion. Then this would be 286 billion, 371 billion, and then 12, that'll be trillion. So that'd be 3,233 billion. Well, I guess I could say 3,233 billion. I guess I could keep it in a billion. So it'd be 3,233 billion This would be 5,674 billion. And then here with 13, you have 13,562 billion. And then we will have 22,618 billion. Now, just to clarify, when we get to the thousands and the 10,000 with the billions, that's basically, we're in the trillions now. So, all right. It says here the population of the United States was roughly 1.23 times 10 to the 8th power in 1930 and 3.3 times 10 to the 8th power in 2019. If the national debt were to be paid off by dividing the total number evenly among all citizens, how much would each have owed in 1930? What about in 2019? All right. So we're going to need the calculator, but let's just first do this. Okay, we want to know how much the population will owe on the national debt. So let me see. How much would each have owed in 1930? So we would have 1930, the national debt was 16 billion. I want to write that out. 16 billion all over the amount of people here. Population of the U.S. was 1.23 times 10 to the 8th power. So let me just write it out. 2, 3, 1, 2, 3, 1, 2, 3. Okay, this is what this looks like written out. So this is the 1930. And then I'll show you how we could type this in the calculator without it being written out. So we got 16 billion divided by, look like 123 million. Okay, so basically everybody would have owed $130 and about 8 cents. That's the whole population. Women, children, babies, adult males, just everybody would have owed that. Okay, so now that's 1930. Now let me show you how this would have looked if we would have did it in the scientific notation. So we would have had 1.6. Let me go back up here. Times 10 to the, what's that, 10th power. And then we will go to the bottom here. And we had 1.23 not divided by, times 10 to the 8th power. And it would have gave you the same result. So either way is fine, depending on your preference. So that's how much would have been owed in 1930 by everybody in the population of the U.S. All right, so now 2019. In our numerator, we would have had the debt is 22,618,000,000,000. All over the U.S. population would be, let me see. All right, so that would have been 330 million. All right, so let's put this in the calculator. 22,618. All right. Now we have to do our 330 billion. All right. So now everybody owes $68,539.39. Wow,
That's quite a change.
that's a big difference. Now it makes me wonder, had they paid it off in 1930, we might be in good standing right now. Woo.
$130 doesn't seem so bad.
Yeah, it doesn't. I mean, I guess if you was a newborn, I guess that would have bankrupted you before you even got started. But yeah, that's quite a lot of debt there. And I guess what the issue is that it just keep getting larger because keep borrowing money and interest keep going up. Yeah. So did you all have any questions on section 1.6? Because we are actually done with section 1.6.
That went very fast.
Oh, yes, it did. All right. Well, if there's no more questions, then I will see you all on Tuesday. And make sure you complete the worksheets and everything that's due this week.